Hey there, and welcome to Gemma Fine Tuner. With this application, you can fine tune Gemma family of models without writing any code and with a very simple, intuitive web UI. So, in our dashboard, you can see some recent datasets and training jobs. Let's look at more text and multimodal datasets. So, for example, this vision dataset, which we can look at a split that contains some messages that we pre-processed from a raw Hugging Face dataset. And I'm gonna show you how you can actually create this yourself. So with our application, you can just copy a Hugging Face ID. Let's just refresh that and paste it here. We're gonna guide you over checking the subsets, the splits, and also previewing some rows from the dataset so you can get a good idea of what a dataset is about without having to switch over many tabs. You can also upload custom datasets, so everything is the same except that this file is uploaded first and then pre-processed. So here, for pre-processing, you can just create a dataset name, uh, and write up some system messages that fits your task. In this case, maybe you are a helpful agent to write latex from images. Whatever you think is appropriate. For user messages, we can say write the latex code for this image. You can also reference column, so for example the text column, but it's not needed in our case, since for the assistant message we're just going to grab the text, which is the correct answer for the latex code, and we should turn on vision and add the vision column, add an image column, which is the latex image. And we can create different splits configuration. For this case, we're just going to use a manual split using the train split from Hugging Face with a 0.2 split size, and we were going to use less samples for it to be quicker for the demo. And you can also use augmentation if you are dealing with text datasets. So we support methods that use NLP or methods that use GenAI. So using Gemini to expand with synthetic examples. So we're going to expand this later to support vision as well. But for now, it only works for text. So let's just pre-process this. Yeah, we're done. And we can look at the two splits. They all look very similar to the sample that we've created. So this is how you can do pre-processing. And after that, you can take these datasets to create a new training job. So first, you would select a model. So for example, this model would support a vision fine-tuning. And you can select the dataset that we've just created and create a job. So for example, unslav latex agent, well, latex agent is good enough. You can choose methods such as LoRa, QLoRa, with PEFT, or a full fine-tuning if you prefer, and configure different other parameters here. You can also paste in your weight and bias and API key in a project. This would allow us to use weight and bias for cloud logging, and then you can just check your configuration and submit this. I'm not going to do it right now since we already have a lot of jobs here that we've created this way, and the status is also indicated right next to these jobs. So it's very easy to see which jobs are training, which are in blue actually. And those jobs, if we went to one of the jobs that are still being trained, it's gonna pull the backend automatically every 10 seconds to see if the status is updating, as long as it's not completed or failed. And in this case, we did turn on cloud logging, so you can actually track the model's training progress right after the job is created if you provided your weight and bias API key. So these metrics are going to be logged to cloud and updated in real time if you turn this on for training. You can also try batch inference, which pretty much for this agent which does SQL generation. In this case, we can select some samples from the backend from the datasets, and we can run batch inference, which which will let you have a quick understanding of how good the model is performing on these samples. So here are the results for batch inference. You can see the result that a model generated and the ground truth, which is basically like the correct answer from the dataset. Yeah, so this is a quick way for you to see if the model improved, but we're also going to introduce a more formal way to use the test sets that you've created before for a formal evaluation with like more metrics. And this is it for the demo, and I hope you liked our application, and I'm looking forward to getting more feedbacks to make this application even better. So thank you very much.